But in order to keep the bubbles sufficiently small, it is necessary to wait longer at depth. This is the origin of the deep stops. Decompression stops at greater depths than usual. Let's consider a real example. For a dive up to a maximum depth of 165 feet, we could have a deep stop of 1 minute at a depth of about 70 feet. Let's summarize the characteristics of decompression models prior to the event of the RGBM algorithm. Decompressions with the dissolved gas models established that the gaseous exchange was determined solely by the local gradient. A higher local gradient corresponded to a higher rate of exchange, staying in any case within the parameter established by the Haldane principle. In practice, this was done taking the diver directly to a point near the surface. But this model did not take into consideration the phenomena tied to the presence of gas seeds. In fact, in the human body, we can estimate that the gas present is 90% dissolved in the tissues, while the remaining 10% is in the form of bubbles. The study of the bubble mechanics makes it possible to keep their number and size within set limits. Other peculiarities hidden in the study of microbubbles are the importance of the rates of ascent and descent. Departure from the bottom must be slow because that is where the first bubbles form. And then 33 feet per minute up to a deep stop, and again 33 feet a minute from the deep stop to the decompression stops. During the descent, it would be advisable to descend quickly, at least 66 feet per minute, compatibly with the problems of inner ear and sinus pressure equalization. This behavior allows the bubbles, which are already present in our bodies anyway, to undergo a rapid reduction in volume, a phenomenon known as crushing. Now, let's compare the same dive performed using the old dissolved gas model and using the new RGBM Myers-Winkie algorithm. The RGBM Myers-Winkie algorithm, while employing nearly the same dive times, noticeably increases safety margins. RGBM Myers-Winkie, the algorithm of the future for safer dives.